So now let's take a look at this sensor we are talking about. How is it able to detect the line? So the sensor we would be using is an IR sensor, commonly known as IR sensor. It's actually infrared sensor. Infrared as in light spectrum infrared. So how does it actually works is that it contains a pair of two, you can say, bulbs. One is transmitter, and the other one is receiver. Sorry for my spelling mistakes. Here is, let's say, the surface we want to detect the color of. So now we know that the black color absorbs more light, uh, and the white, it absorbs less light, right? So let's say we have a black surface here. For now, let's say we have a black surface here, and the transmitter emits these packets of infrared lights. It's This black color absorbs most of it, and very few are returned back here, so which this receives here. Now here is a black box. Let's say here is a circuit. This circuit knows how much intensity of light it sent and how much it received, and there is an electronic circuit. Based on that, it can detect you. It can either give you an analog value, or it can give you a digital value. It depends upon the kind of sensor you are using, either analog. They are both analog IR sensor and digital IR sensors. So we will be using the digital one. The digital one now comes with a threshold. This threshold rheostat, this is basically a rheostat, and it's a variable sensor, a variable resistance. So it measures, let's say, here is a graph, let's say, and the received intensity lies here, right? So if this value is above here, it will return us 1. This digital pin, let's say, here is output, and otherwise, if it's below this intensity, it will return us a 0. So based on this, we can detect the color of the light, the color of the surface. Now keep it in mind that the to detect the color, we have to keep it at same distance. This distance should not vary, this distance, otherwise the readings won't be accurate. This IR sensor is actually also used and mainly used to measure distance, based on the same principle, the amount of light absorbed. So if you are we're not just to give you an idea of how that works. Let's say this is actually here, this object actually lies here. So if it's far away, we will be receiving much less of the light, right? And again, we based on that we can detect the distance, but that's not what we are focusing on right now. So let's say now here we have let's say we have a white surface, right? Right here, and we the transmitter transmits light, and much of it is very less light is absorbed by this white color, and much of it is reflected back. The received threshold is now much higher, and let's say we set the threshold now here, it will return us 1. Now we actually have to tweak this sensor here, this rheostat here, to get a difference to of these two colors, of these white colors and black colors. So it's a little bit of tweaking, but let's say here is the output voltage, 0 volt, and let's say the sensor is operating at 5 volt. So if it's this is the 5 volt, let's say, then if this is 5 volt, then it can be let's say black color, and if it's very low, approximately equal to 0 volt, and then it is let's say white color. To summarize this all, uh, to summarize this all uh, so this is how the IR sensor works. To summarize this all, let me just redraw this all. We have this IR sensor module. It comes with the transmitter and the receiver, and here we would have 3 pins. Here is one would be VCC. It would be, let's say, plus 5 volt. We would be providing this plus 5 volt from the battery, from the positive terminal of our battery, and here is the ground that we would connect to our battery, and here is the output pin. Based on the color of the substance, here we would get an some output here, some digital output here, right? So in short, if it's a black color, then output is, let's say, 1, and if it's white, then output is 0, right? So all you have to do is keep this table in mind. Now, how we are able to detect our line based on this. Again, it's really intuitive and really simple. This is our line. It's actually black and white, right? And here is, let's say, the line. And if you would look from a side view, let's say here is a side view, then here is, let's say, our line, and here is our robot, and this is the sensor, right? This is the sensor, this is the robot, and here are robot wheels, and this is the line it's trying to detect, right? So it would be in this range, and it would be detecting the color of the line according to this graph, right? So here would be the sensor. It would send the IR, receive the IR, and this analog to digital converter circuit would convert, and we would get this digital output. Now, this if you're new to electronics, this all might be a little messy, so I would suggest you to go through the video once again, write all this stuff down, try to understand it, and if you have taken some basic courses in electronics, it would all be really intuitive for you. So for the remaining course, all you have to do is really keep this chart in mind. Now, for some sensors, this might actually be opposite. We might actually get a logic 0. This is a logical output. Please remember, this is logical output. 1 actually corresponds to plus 5 volt, right? For some sensors, it might actually be opposite. The black color might correspond to a logical 0, and the white might correspond to a logical 1 or plus 5 volts. It depends upon different kind of sensors. sensor type, so which sensor you are using. But for this course, for this course we are going to go with this logic, right? If there is a black color, if we detect a black color, we get plus 5 volts and a logic 1. And if there is a white color, we get a logic 0, or you can say it's ground. So, in coming lectures, we would see how our line following logic is linked with this truth table.